So dormer calculation, our in-class example. So information that's given there is span of 10 feet. Okay. I'll do this in red there. So span of 10 feet. The dormer slope, you can kind of see the axis, right? The dormer is 7/12 slope, which basically that's the dormer right there, right? So this triangle is similar to this one right here. Okay. So 7/12 dormer slope. The main roof, right? This is kind of representing the main roof here. Kind of missing there on the drawing there, but that's the main plane, the plywood. The slope of that is a 10/12. Okay, the main roof. So again, this triangle over here would be similar to this triangle, 10/12. So it's basically an unequal pitch blind dormer that we're trying to calculate here. So just kind of breaking it apart into triangles. Okay, so the span is 10 feet. First thing we want to calculate is triangle A. So if I take the span and I divide it by 2, so 10 feet goes from there all the way to here, right, 10 feet. So if we take the span divided by 2, we get the run. The run is from here to here. So that's 5 feet, okay? So we could then transfer that information over here. So triangle A right here is also drawn right here. So the run is basically 5 feet there, or we could say 60 inches, okay? Total rise is the distance from here to here, which is the same as what we have from here to here. So rise, total rise, right? A couple of different ways we could do that. We could use similar triangles to figure that out, comparing it to the 7/12 roof, or we could use our formulas that we kind of use in class, which is basically for total rise, we go run times unit rise. So the run, basically there's 5 feet here. That means there's 5 feet of run. That means there's 5 triangles there, right? So basically we'd go 5 triangles times the unit rise of 7. That's the unit rise of the slope, 7. So 5 times 7 is 35 inches. Okay, so that distance there is 35 inches. Once we have that, we could use Pythagorean theorem to solve LLCR, or we could also use our formula there as well. So the formula in class for LLCR, we use run times UCR. So UCR is basically the slope of this triangle. So the hypotenuse is UCR, right? So we call that 13.89. Where do we find that? We find that on line number 1 on the square. Or we could use Pythagorean theorem using these two numbers to solve for the hypotenuse. So basically the run, there's still 5 feet there. That means there's 5 triangles. So it's 5 triangles times 13.89. So that's going to give us our LLCR. So 5 times 13.89. That gives us 69.45 inches. So 69 and we'll subtract the 69, left with fractions of an inch. So multiply that by 16, that gives us 7/16 there. So there it is. So maybe we'll just come over here and label that so we know that that's 5 feet. I'm just going to write 60 inches there. That total rise there is 35. And that LLCR is 69.45. Leave everything there in decimal inches. Okay, so we have triangle A complete. Now we have triangle B that we're going to work on next. So that's going down the center of the building there. Okay. Off of that, right, total rise hasn't changed, so that total rise is the same for A and for B. So we can write that down. Center line we don't have yet, and ridge we don't have yet. So you can see that that triangle is comparable to the main roof triangle. So I'm just going to put a little main roof triangle right here that we can actually look at and compare. That's 12, that's 10. So right now we know this, and we don't know anything else on the triangle, right? If we know that this angle here is the same as that angle, this angle is the same as that angle, so we could in theory use similar triangles to solve for the ridge. That's basically a fraction, and that's also a fraction. So I'm going to come over here and I'm going to make this fraction as r over 35, and I'm going to use similar triangles. R is horizontal, it's equal to the 12, so R is equal to 12, 35 is equal to 10. So this fraction, which is this one, is equal to this fraction. we're just going to cross multiply that. So when I cross multiply, it's going to be 10 times r, so that gives me 10r. And then it's going to be 35 times 12. So then I want to get r by itself, so I divide by 10, that cancels out. Whatever I do to that side, I do the same to this side. And then I get an answer for r. So r is equal to basically 35 times 12 divided by 10. Right, 35 times 12 divided by 10, 42 inches. Okay? So r is 42 inches. So write that up here, 42. So that's done. And now we just have to solve that center line. This is the center line right here. Right? So I know two pieces of information on a right angle triangle. How do I find the other one? I basically use Pythagorean theorem. So I'm going to solve for the hypotenuse. So if I take the square root of these two numbers and add them together, right? So the square root of 35 to the exponent of 2, and 35 to the exponent of 2 plus 42 to the exponent of 2. So 35 to the exponent of 2 plus 42 to the exponent of 2, and then square root that answer. I'll then get the hypotenuse. Okay, so I'll bring that over here, press the square root button, open the brackets, 35 plus the x squared, so I'm going to see exactly what I see here, plus the 42 x squared, close the brackets, so that's exactly what we have, press equals, there's our hypotenuse, 54.671 inches. I'll write down 54 here. Subtract that out of the calculator. I'm left with fractions of an inch. I multiply that by 16 to get the numerator. Numerator's 10 over 16, but because that's 5 or higher, I got to make that 11. So 54 and 11 sixteenths. Okay. And there it is. That's done. So we know the ridge is 42. That center line is 54 and 11 sixteenths. Right, that center line right there. So we'll almost have what we need. In reality, like I was saying in class today there, that triangle A and B are kind of all you really need to be able to build the dormer. The rest of the way here is just mathematics that you could kind of measure on the building itself. So we'll continue here. We're going to go ahead and calculate for C now. C is this triangle right here. So we already have two pieces of information off of that. We have the center line, right, which is 54.671. So you can write that in decimal form here for calculations. The run hasn't changed. It's still 60, right? There's C, 60 across the bottom. The only thing we don't know is the valley length there. Okay, so again, we could solve that by using Pythagorean theorem. We know two sides are missing the hypotenuse. So we'll go the square root of 54.671, the exponent of 2, plus 60 to the exponent of 2, and then square root that. So square root brackets 54.671 x squared plus 60 x squared, close the brackets, press equals. We get 81 there. 0.172. Okay, so 81 end, so subtract the 81, multiply the leftover by 16, gives me my numerators at 2 sixteenths. That's 5 or higher, so we're going to make it 3 sixteenths. Okay? We want to go ahead and find that angle, right? So that's going to be the valley board, right? That's the valley. So we're going to have cut a board here that the valley jack rafters are going to sit on. So we kind of need to know those angles, right? We're going to go ahead by trying to find this angle first. Once we know this angle, the angles inside of a triangle equal 180. So if that's already 90, that means these two angles here have to equal 90. So once I find this one, I'll go 90 minus this angle, it'll tell me that angle. So just do the work once. We're going to use TOA, right? We're going to use TOA to find that, similar to what we did when we did our stairs. So what is TOA, right? SOHCAHTOA. So basically we're going to use the tan of -1 opposite over adjacent to solve for the angle, okay? So this is the angle we want, so that's going to be opposite. This is going to be adjacent. If I wanted that angle, this would be the opposite. That would be the adjacent. This is always the hypotenuse. So in this case, I want this angle. So I'm going to use that formula where my opposite is the 54.671 and the adjacent is the 60. And then that'll give me the angle for that corner. So I got to make sure my calculator is in degrees. If it's not, I could press the DRG button here. There's rads, gradients, and then degrees, okay? So I'm going to go second function tan, which shows me exactly what I have here. Open the brackets, I'm going to go 54.671 divided by 60. So that's exactly what we have there. Press equals. There's my angle, so 42.339 degrees. So that's the actual angle there. So 42.339 degrees. But if I'm actually going to build that, I actually have to cut to the opposite. Cut opposite angle. Which is going to be that minus 90. So I'm just going to go minus 90. It's going to give me a negative there, but so it's cut to actually 47.66 degrees. So why do we have to do that? So we talked about that in class today, but so this is the true angle, right? 42.339 degrees. We actually have to cut it at 47.66 degrees because of the way tools are made. Well, when you go up to a miter saw and it's set to cut a 90-degree board, the miter saw actually reads 0 degrees, right? So it's the opposite angle. Circular saws are the same way. Whenever the saw is set up to cut a 90-degree cut, it's actually set at 0 on the miter gauge. Speed squares are the same way. Whenever you're drawing a 90-degree line, it's saying it's 0 degrees. So they kind of all work in the reverse manner. So, but like I was saying before, once we know this angle, if we go 90 minus this angle, we get that one. So in reality, this angle at the top here is 47.66 degrees, but you would cut that at the opposite, which would be 42.34 degrees basically. 2 decimals is plenty there. So that angle in reality is 47.66, but that angle there I'd have to lay out to 42.34 degrees with my speed square. This one here I would have to set up to 47.66 degrees to be able to actually cut it with my speed square. The bottom of those valley boards is also going to receive a bevel. So it needs a bevel there. That's a 90-degree cut on the face. This one here has to be beveled to the main roof slope. So as it comes down, same as this common rafter at the front, it has to be beveled to the angle of the main roof. So if there's basically a rafter coming down here, that rafter is not square, it's an angle. So the angle on the valley board and the angle on that common rafter are this angle right here. Right, so we probably should figure that out as well once we're done. Figure out that angle using the same method. Tan of -1 with the opposite. So I want to know that angle, so the opposite's 12, the adjacent is 10, and that'll be the angle that I have to set the saw to cut that common rafter and to cut that valley board at the bottom. Okay? We're there now, might as well finish it there. So we'll just go second function tan, brackets, 12 divided by 10, close the brackets, press equals. We got 50.19 degrees. So again, cut opposite. Cut at opposite angle. So minus 90 gives a negative number, but that's fine. So that's 39.8. So it actually set the saw to a 39.8 degree to cut that angle there. Okay. We'll look at. I guess I could pull it up right now just to kind of show you exactly what I mean by the angle. So there's the drawing that we had in class today. So this is actually SketchUp here. I'm doing this from my laptop, so I actually have SketchUp on there, but that's kind of what I mean there. So we just figured out the length of the valley board here. We figured out that this angle here on the face has to be 47.66, but it's also beveled. That's what I'm saying there. It's beveled to the angle of this roof. This is a 10-12 slope. So we found out this angle here at the bottom is 50.19 degrees in actuality, but to cut it, we have to cut the opposite, so 39.8 degrees. So we'd actually set the saw at 39.8 degrees to cut that. Same for this common rafter. It'd be set at 39.8 degrees. So we know the distance from long to long, we calculated at 69 and 7/16. So there we cut a 90. Over here we cut a basically a compound miter, but the bevel on the saw, so the circular saw would be set to angle 39.8 degrees. We'd follow that line and it'll produce that angle for us, and then that could be then installed. That valley board would slip behind it with the exact same angle. So the angle at the top of that valley board would be the 42.34. So we'd actually lay out 42.34 with the speed square, but leave the saw blade at 90. Okay? And then that would give us the cut. So you can see on this side of the valley board, I got it chamfered. And on this side of the valley board, I just simply have it stepped back. Okay? So let's continue with the math there. I'll get rid of this picture for now, so we can finish off the math. So now we're going to move on to D. Well, there's triangle D right in the corner right here. See it right there as well, right? So D's triangle is similar to C. It's the same angle. Right? The angle that we see on the big C triangle is the same angle as D. So where does that come from? It starts off here, where this here is actually 12. Right? So that one's always going to be 12 right there. This here is going to be the unit rise of the main roof, which is 10. So we're going to have 10 right there. And then basically what ends up happening is that's triangle D. So where the hypotenuse of that triangle is 12, so that's the hypotenuse right here. So that's going to be 12. So that's going to be 12 there as well. So we're trying to solve for x. So we want to know what is x. X is the bottom here. So we know all the information off of this triangle. We need to use these two numbers here to get x. Right? Those two numbers are a fraction, and then 12 and x are a fraction. So we'll just do that right over here. So I'm going to put the decimal here. So we're going to go 81.172 on the top. I'm going to put the 60 on the bottom. Now I have to make sure I compare apples to apples. That's the hypotenuse. Hypotenuse is equal to 12. So hypotenuse equal to 12. 60 equal to x. Then you cross multiply. So basically we're going to go that times that divided by that is essentially what we're going to do. If I do it the long way, I'm basically going that times that, which is going to give me 81.172x is equal to 60 times 12. I want to get the x by itself, so I divide by that number. I do the same to that side. Then that leaves me with x by itself because that's canceled out. So I basically go 60 times 12 divided by 81.172. That gives me x as 8.87 inches. Okay, so x here at the bottom is 8.87 inches. So I'm going to leave that in decimal because it's all, most of this stuff is for calculations, right? There's only a few things that need to be in fraction form. Center line, I have it in fraction form there. So if you want, you could rewrite that down in fraction. Make sure all your answers are in fraction on the drawing. Okay. The angles are fine in decimal. That one there I have in fraction form. I could convert it as well, though. I could go minus 8 times 16. So 14/16, so 8 7/8 basically. I'm going to use that number for calcs though. So I can then pull x over here, right? So when we figured what x was here, it's basically 8.87. That means I also have 8.87 right here. That's 10, that's 8.87. I want to solve for that little angle there, which is this triangle right here, where the bottom is the 8.87. and the vertical portion there is the 10. And I want to know that angle. So if I want to know that angle, I use the tan of opposite, which is 10, over adjacent, which is the 8.87, and that'll give me the angle. The true angle, we got to cut the opposite though. So second function, tangent, brackets, 10 divided by 8.87. Oh, make sure it did. I didn't put the brackets on there. Just see if it makes a difference. Second function, tan, brackets, 10 divided by 8.87, bracket. No, it's the same number, so 48.426 degrees, so right 48.43 there. Cut opposite. So cut at opposite, so minus 90, 41 point, basically 6 degrees there. One decimal is enough for degrees. So when we go to bevel that piece, we're going to set the saw to 41.6 and we're going to rip it. Okay? So basically we have all the numbers there. So the valley board that we're going to rip to 41.6 degrees is right there. Right? That's the valley board. That's the bevel that we have to do. So if we set the table saw to 41.6 or circular saw to 41.6 and rip that board, we can then cut the length. So we know the length of the valley board is 81 3/16 from this point all the way to the center. Okay? So that's 81 3/16. We then have to reduce that though by the thickness of the ridge. So we'd have to remove 3/4 of an inch off of that line parallel. So from that line, go over 90 degrees and measure over 3/4. And over here, we'd have to remove this direction, 90 degrees off the bevel here, 1.5, right? So we have the theoretical, take off 1.5, brings us to our cut. Over here, we'd have the theoretical. From the theoretical, we have to go 3/4 of an inch off of that cut. And that will make that fall into place. Or like I was saying in class, install a common, brace it temporarily, plumb with a strapping back to the roof. And then you can actually measure that distance. Once that ridge is installed, you then measure this distance. We know the angles, calculated those angles, that's pretty straightforward. And then we're kind of just stick framing from there. So another option instead of beveling is to step it back, which I think is probably more realistic. So if you were to do this, just take a scrap piece of material, cut to this proper angle. So we know that the angle at the top here, so if this was a 2x6, we can grab a 2x6. We know the angle at the top is supposed to be 42.34. Right, so we take our speed square marker 42.34 here on a scrap piece of wood. I'm going to try and move that now. So I'm going to click on that piece and I'm going to move it. Okay? So if I move that out of the way, so kind of what you'd want to do is once you have that angle cut correctly, you'd want to take that point and line up that corner to where the ridge and where they make contact. So you want them to physically make contact from this point to the ridge. That's where plywood touches on both pieces. Plywood follows this top edge on the valley board. Plywood follows this edge on the ridge. So when they come together, you want to basically put a pencil line right here. That's what I was trying to explain in class today. So when they come together at the right location, you put a pencil line right here at the bottom. Right, so once I put a pencil line here at the bottom, I then know my step back for that valley board. So let's say this is 1 7/16. I would come over here off that chalk line, go 1 7/16, and then snap a chalk line. Well, that valley board would sit right on that line. Then what's going to happen is it falls into the plane of the roof. Right? So we kind of tilt that, follow. So the plane should hit this chalk line, that edge of the valley board, and then the common rafter. So I'm just going to try and slowly roll that up. They should all meet together if it's done right. See how they all kind of come together there, nice and clean? The bottom's off a little bit there, but just because of the drawing, but at the top they're coming together nice and clean. Okay? So that means it's stepped back correctly. Okay? That's probably the most realistic way of doing it. So then what you could do is once you chalk that line, you can measure from the chalk line where it hits the ridge. So where the chalk line hits the ridge, hook on, or have somebody hold your tape. And then you're going to measure down to this point where the chalk line hits the common rafter. Measure that distance. That'll be your length from long to long for that valley board. And then no math is required. Okay? So kind of what do we have right? So if we didn't have all this wood in place, so I could probably remove that wood. Windows, layers. Where's that triangle? Anyways, maybe rather than take that all apart, but so if I was to start off by building this, the first thing I would do is start laying out chalk lines. So for the example that we're doing, this span was 10 feet. So the first thing I'd want to know, where's the dormer on the building? So what is the distance from, let's say, this edge to the center of the dormer? So maybe that's given on the plan as 15 feet. So I'd hook on the corner of this building, I measure over 15 feet. That gives me the center. It's a 10-foot span, so I might measure over 5 feet. Then I measure over 5 feet. Then from there, I have to create 90 degrees here, right? So I'm going to do some kind of interval of 3, 4, 5 to actually achieve that 90 degree, right? So I might go, right, we could go 3, 4, 5, 6, 8, 10, 12, 16, 20, 24, 32, 40. We could go 48, 64, 80. That might be maybe even closer, right? So we could measure over 48 inches, put a mark here, measure up 64 inches, kind of with your tape measure, make an arc. And then from that 48-inch mark, swing another arc at 80. And that'll actually allow you to find the center, right? So if I, and then I chalk a line through that intersection up the roof, that gives me the center of the dormer. Well, we did our math, right? So we know that the distance from here to the very top, so what we're calling the center line on our assignment, right? The center line. This distance right here, the center line, how much do I measure up that chalk line is 54 and 11/16. So we could then measure up 54 and 11/16. From there, chalk a line down, chalk a line down. From there, I'm pretty well ready to start building. I can cut these two common rafters. Right, so we know the distance of that common rafter from long to long is 69 and 7/16. Right, so I could take my frame square, set it to a 7/12, draw a line on the 7 side of the square here, then hook onto that long point, measure 69 and 7/16, take my framing square, 7/12, set, mark the 12 side of the square on this end. Then I can set my circular saw to the angle of the main roof, which we determined to be 39.8. So set the saw to 39.8. Put my base of my saw on top of this surface, and then cut the angle following that line. Right, so the saw is going to follow that line. The blade's tilted at 39.8 to make that cut. Then I set my saw back to 0, which is 90 degrees, and then I follow that line, make a cut. So I do the same, make a second one that's made up for the left side. Install that onto the building, so a couple nails down here into the fascia, a couple nails down here into the fascia, nail those two together. Grab a level, make sure this is plumb from this edge to the fascia. When it is, I'll take a strapping, put 2 nails into the strapping, extend that strapping over onto the roof, nail into structure, holding these 2 components plumb to the main roof. Then what I can do is then look at cutting my ridge. Right? My ridge is basically going to go from here, theoretically, from the very outside edge to that point on the layout. That's where the chalk lines come to. So you can see the ridge is actually a little bit lower because it has thickness. That's where the theoretical is, from that point to there, which we calculated to be 42 inches. Right, our ridge is 42 inches, theoretically. So I think in class we said we were going to remove 1.5 inches from here, and then we did the math on this one here, ended up being 0.5 inch. Right, so we took the vertical distance here going up, and we actually measured from here to here. I'm not sure if this drawing's to scale. It is, so it's 0.5 inch. So we did the math today, right? We used our little trick to solve for x, right? So if this is 3/4, this is x, the same way we figure out our ridge pole. So if it's a 7/12 slope, that's 7/16. We then determine that to be 0.5 inch using similar triangles with the 10/12. So if we took off 0.5 inch here and 1.5 here, that would leave us with basically a 40 inch ridge board. So if we actually hook on here, measure, see if it's 40 inches, we'll know if this is the scale for the math we're doing. So 3'4". Yeah, so exactly 40 inches. Okay. So that would be 40 inches to the long point of a 1012, right? So the main roof here is a 1012. So you'd hook on, measure over 40 inches. You set your frame and square to 1012, and then you would draw a line from this point downwards on the 12 side of the square. That'll give you that cut. Okay. And then we'd move on to the valley boards. Again, which we kind of already discussed there. The angle at the top here for that valley board would basically be cut at 42.34. The bottom angle here on the face here would be cut at 47.66. We'd have to either bevel or step back the valley board. So if we're beveling it, we're beveling to a 41.6 degree. Okay. Or we step it back. So again, instead of using that formula of solving triangle D, solving triangle E, if you had a scrap piece of material, found this chalk line, like I was saying in class, if you use this number with this number, it'll give you that bevel angle as well. So when you're determining the step back, for some reason, if you change your mind and you want to actually bevel it, that's also the bevel angle right here. So if we quickly do the math with that, so basically if we want to find this angle, the opposite is that distance, which is 1.5. And I'm just going to measure what this is right here. So that's 1 3/8. So basically the math to find that angle would be second function tan brackets opposite, right, so opposite of the angle we want is 1.5. So I'm going to go 1.5 in my calculator, divided by, we just determined that to be 1 3/8 approximately. So it's not exact there because the drawing's probably not perfect, but we'll just see what we get for a number there. So I'm going tan of -1 brackets 1.5 divided by 1.375. Close the brackets, press equals. We end up with 47.4 as the true angle. So a little off. It's not, the drawing's probably not 100% there. But that should give you the right number if this was correct. You can see I'm off a little bit here at the top. I'm off by almost 1/8 of an inch. I'm not sure if I'm exactly 90 degrees there, so it's slightly off, but if this was done with a piece of wood, in reality, that would be bang on. Okay, so I'm off just a touch there because of accuracy. Okay, so hopefully that kind of makes sense, comes together, right? You can see that's the dormer with the components put in place. I wanted to show you that in class today, but for some reason it wasn't opening up. And there's the math we did, all the theory, right? So our chalk line's 10 feet. Find the center, make a 90 degree, go up, measure up the center line distance, which is 54 and 11/16, chalk a line to the bottom corners, and then start to put it together. Okay? So we'll leave it there. So there's the kind of the finished dormer. There's a valley jack in there. Normally the valley jacks are just measured over, parallel to the common rafters. Right? So if this was a long stretch, you might just brace that so it's straight. And then we can measure our rafter spacing. So if it's 16 inch on center, we go from here 16 to center, back 3/4. 16 to center, back 3/4. And then we just tape that off. Rather than do any kind of fancy calculations there, just measure that distance is probably the easiest way on a job. The key is to make sure that this is straight so we can actually measure off of it accurately. Okay? I guess that's it.